Good afternoon, everybody. My name is Navis from a group called ASD, Andromeda Software Development, and I'm going to talk to you today about how you are going to build the next demo masterpiece. I've been to assembly, now it's my 5th time with my group. Each time we come here, we bring a demo. We've made ASD back in '92, so I've seen quite a lot of things in my life with regards to demos, and we've gone the demo competition twice in the past. We actually bring a demo this year too. So I'm going to speak to you today about making demos, but not so much from a technical point of view, more from an artistic point of view. I understand that lots of people in my audience actually maybe don't even know what a demo is, or even if they do, they haven't made their own demos. So I would start, if you want to make a demo, by asking yourself, why would I like to make a demo? And it's quite hard to put your finger on it. Some people say, I want to do it because I want to show off what I can do to my friends, what I technically can do, or I want to prove myself that I can start something and I can finish something, or because everybody seems to be doing the same. So there seems to be some sort of peer pressure between me and fellow demo makers. Other people, and that's also quite common, they like to learn some new skills. Whether you're a coder, I am a coder, whether you are a graphician or a musician, you always want to improve your skills and learn something new, and that's fine. And of course, there is the odd opportunity which you have at the assembly or other parties. You can gain some fame and fortune. Everybody will be talking about your next big piece. It's still a very big challenge, and I think before starting, somebody must sit down and realize, first of all, if you do it for all the reasons that I've talked to you about, then I think that you're in the wrong path. And I think this presentation of mine will help you a bit. So principally, I'm going to show you how to improve your demo making process and how to improve the quality of your work. Again, what is quality? This is a very subjective thing, isn't it? But I believe that the way I'm going to talk about this, it's going to become more and more objective. Well, you start and you say, how am I going to make a demo? There are two different ways that you can make a demo. You can either start by using somebody else's work or your work, that is a tool, to use something like Addict and Demopaya, which was made by people from inside the scene, which is, depending on your skill and how well you understand this piece of software, it can be very, very hard or quite easy to use. Or you can do what we do, which is to do everything in C, C++, using a set of libraries that you develop or you get from somebody else anyway. So we use a set of libraries that's very minimalistic. Actually, I'm going to talk to you about that in a bit. There is probably a world in between the two things where you use, let's say, lots of libraries and from other people and make something by coding on a very high level. As I said, we do things hard-coded, and I do OpenGL. I use OpenGL, GLSL, and I don't have a wrapper I don't have any wrappers at all. Basically, I like to write OpenGL command as they come. And what's under the hood is really, really simple. There's absolutely no animation engine. There is no proper particle systems. You'll probably think, particle systems, hey, I learned this thing in computer science course. It's so easy. It's object orientation. It's all the nice things that I finally have an opportunity to put that into practice. Yet, I think that there is no need for any of that. There is no need for scripting. There is no need for fancy camera functions, quaternions, anything like that. I think it's just a bit you don't need it. It's still too much. I say that you can, if you are even under your level is under that of an average coder, you can have a demo by tomorrow if you want to, by only taking a piece of code that will just open up an OpenGL window and show a cube, and from that you can build your own demo. It's as simple as that. It's really simple. And you ask the question, yeah, but isn't that more difficult if you're going to make something that's more complicated than the spinning cube? I say it can be. It can be very rewarding. It can be real fun, and sometimes are even faster to make than to make scripted ones. How fast I've made demos that I start and finish them on a single day, and they were still not that bad demos. I asked a question then to people who support the editors: how faster would you do that in a demo editor? They would probably answer, I could do it as fast as you. I'm not quite sure about that. That means that this person has already had a lot of experience in using that tool. And while I will find in this room, around the world, lots of people who could use OpenGL and GLSL or DirectX or whatever to make a simple, good demo in one day, I don't think I would be able to find that many people who could use a Demopaya or what was the Addict or something like that. It still requires a learning curve, and I'm not quite sure if it's worth it. There are some other demos, of course, like Iconoclast was a demo that we made in 2005 and won the competition here, which maybe they are faster to make in an editor, maybe. It took me, of course, a lot of time to make it myself. It took months. But I say that it would be extremely, not just hard, extremely hard to replicate some of the organic motions that you may see in our demos and movements just by using an editor. The reason being is that all of these special movements and special effects would have to be special cases within the editor itself. So you're back to the point of having to do some dirty coding with your fingers rather than with the mouse. So have that in mind. A demo would have different scenes. A frame would start, then there would be some actions, I call them. I'll explain later what happens there, and then the frame would end. There could be many scenes in one demo. By scenes, I mean the different set pieces, let's say, that make up the whole demo one after the other. I say now, I wouldn't say the same thing if you asked me 5 years ago, but the fewer you have, the better the whole thing is linked together. So Life Force, which was our 2007 winning demo, had 12. It was a very big demo. It was 8 minutes, and it had 12 different parts. Iconoclast, which is a code name for our new demo, which you're going to watch hopefully tomorrow. It's not called Iconoclast, by the way. Has 4, and it has the same length. So you may wonder, how is this possible? By stretching those 4 parts to these four parts make up the 12 parts that the Life Force had. They are only 4 because they organically one blends into each other. So for you, for the viewer, it looks like it's 4 distinctive parts. For me, it may be in code, it may be 20 or 50 or something. It doesn't matter. Whereas in Life Force, there were 12 distinct parts, and I think that makes a well-designed demo even better. I say if the scene, not the demo scene, the scene that we were talking about is the canvas, then all the actions are added on top of each other, like on a painting you have brushes added one on top of the other. For example, an action would be a hanging man or a particle fog. And I'm going to mention that very early in my presentation because I think it's very, very important. And it's the very first technical thing that I'm going to talk to you about, is that in whatever I do, all actions, that is again, all things that start and end, that are part of what you see in one scene, have a float value that is associated with a computational effort that the card or the CPU has to has to do. So when there is when this float value is 0, then nothing happens and you don't see anything. When it's at 1, then the effect is played in its full glory, and you may have lots of them at the same time. You may ask, why would you like to do that? What's the point? Here is an example, first of all, where you have something very simple. It's rain. Okay, it draws particles as a loop, and it goes through all particles and it draws them. As you can see, I multiply that by that value, and where this value is 0, then nothing happens. The computational effort is 0. When it's 1, then it draws all the rain particles, max rain particles. So the computational effort is much higher, and you see something. Well, this way, the actions can crossfade. When one starts, the other one will end. Sometimes you have to take the camera away from this. So for in this example, you would have a rain appearing at after the 5th second, and then it disappearing after the 15th second. So maybe at the 15th second, something else starts. So the two things can crossfade. And this is very important, very, very important, because that's how you can keep your frame rate constant. And this is a cardinal error for me, which I've seen it in many productions, where the frame rate just goes up and down. And that will just kill the flow if you intend to have any sort of flow in your demo, and you will kill the enjoyment of what you are presenting. You can extend that principle even when you have something like a mesh, a single mesh. You can say, with the FC, I can control how many triangles there will be drawn. So you have an object that appears. It will appear maybe in a 1/10 of a second out of camera. All the triangles will be indexed within the first 100 milliseconds, then it will appear, then something else will happen, and then it will disappear. And that's how we keep the frame rate constant. It's very, very important. Speaking about this, in my presentation, I must say it might look a bit strange, but there are quite a lot of different directions, lots of things I want to cover in 1 hour, and it's quite hard. When I was asked to do this, I had so many ideas. So I'm going to talk a little bit about everything, and you can fill the gaps yourselves, I suppose. Something we use quite a lot is randomness. You may say, well, I want to do something like a flock of, let's say, birds that fly, but I don't want to go into an editor, 3D editor, and put each little bird and put the curves or how they move. I don't do either. I actually never put by hand more than one object by hand in an editor. I use a random, like srand and the rand command in C. And since a fixed seed would return exactly the same random sequence on all computers, then you can just find the best seed that fits your demo. Let's say that I have a star field, and my stars are actually comets, okay? And I have the camera traveling, and the comets are coming. So I use one srand value, let's say 0, and one comet hits me here when I'm 1 meter into my journey. Then I try the srand with a value of 1. Then another comet hits me here. Eventually, I will find one sequence, one random seed that will just work. Now extend that idea and keep that seed value, because this is a demo. This is it's fixed. There is no interaction. Okay, so I will keep that random seed and use it in my demo. And it's so easy. I have associated the random seeds in all of my animations with, for example, keys. So as I'm running the demo, I press a key up, down, and the random seed goes up or down. And at the point where I find the perfect seed, then I copy-paste it, and that's it. It's very simple, very dirty, but it really works, and it works very fast. I also do modeling for AHD, and of course, because I'm the only programmer, well, there are certain restrictions that I want to follow. I use a program called Wins3D, which is out there for free. I don't use Blender, I don't use 3D Studio. I used to think that, well, if they are programs that you pay money to buy, then they should be better. But for the stuff that we do in the demos, Wings is by far my favorite, and I think it's the best thing. It saves you time. It can do lots of things for you. It will export in OBJ, which I use, which can do soft and hard edges. In soft hard edge, if you don't know, it's the whether you have a normal share between two faces or not. So you can have objects that appear smooth or appear as if the edges are hard and reflect the light with the same normal across the same triangle, which is quite good for certain effects. I used to calculate UV maps where each vertex would have its own associated UV coordinate, either auto-generated or manually through Wings, or Blender can do that. But I don't do that anymore because it's just a waste of time, I think. And time is what I'm talking to you about. It's all these tricks to save you time. And there is no association with textures or materials or light maps or any of that. So I do the modeling, Wings 3D, straight away, export, my program loads, plays, and that's it. Within 10 seconds, you can do that. If I had to do auto UV each time, it was another minute of delay. If I had to associate with textures, another load, save, something. Each of these clicks, if you think that my new demo has about 160 different models, so imagine how many times I saved and load these models myself. So multiply that by, let's say, 2 extra minutes, and that's all my holidays covered. So that's I think that's my way of doing it. You may ask me, of course, well, where do your UV maps come from? Yeah. Well, you can generate from inside the vertex shader using the face normal information if you're using hard edges. So if the normal is pointing, let's say, this way, then you do a projective texture with a plane on those faces. If it's this way, then this way, and so on. So like a sort of a cubic map, let's say, cubical mapping. And it works pretty well. It is good enough for the kind of stuff that I want to do. If you want to do, let's say, a character that is modeled that has a face, hair, wears clothes, then obviously you have to do some UVing yourself. I don't use textures. I only use 3 or 4 textures that are generic noise textures. I talked to you about previously about my new demo. And in this demo, although it has all these models, there are only 4 different textures in the whole demo, and that's it. You will be surprised, but whatever you will see, it's only 4 textures, and that's it. And you can emulate the light maps using the screen space ambient occlusion and some shadow trickery. You can do quite a lot of things with without having to leave the Visual Studio, what I use. You can do quite a lot of things with code these days. A pipeline for the texturing and coloring and rendering would then be, my faces would have the fong reflection, so ambient, diffuse, specular component. The texture mapping, as I said, with my auto-generated UV maps. Then you can emulate, and this is a really nice effect, a spotlight, how it hits surfaces, using projective texture mapping, where you have a projection of some, and that some doesn't have to be a blob, which is what you get when you have light like this hitting a surface. Here you can see something like that. It can be multicolored blob. It can be the light coming out of through the windows of a church, for example. So you can make some really interesting effects with that, and it's almost for free. Then fogging, where objects far away are actually dark or lighter than objects quite close. You can do, and that might sound a bit strange, but I have a function that change slightly, and that's the key with all these things, is that you should not be rough. Whatever you do with these things, there has to be just a little bit of everything. There are quite a lot of things that you can see in my list, and the list goes on, but just a little bit of everything. The color change depending on based on the normal orientation, the orientation of the faces, that is. So I don't know why it works, but it does. It makes things look a bit more realistic. yeah, shadow mapping, which shadow mapping and the ambient occlusion, they require quite a lot of work to get them working, actually, because you have to use multiple rendering targets and all that. But I think it's really, really worth your time. If you can get the last two working, which are hard, maybe not so hard nowadays with the new shaders, you can do lots of things that you couldn't do 8 years ago. But if you manage to get these things working as well as you can get them, and then do your demo, then your demo is going to look so much better. Yeah, and then once you have that done, then you can have for the whole screen some sort of a camera jittering and the full screen smearing. You know how the camera moves, and because the lens stays open for a finite amount of time, you get some sort of blaring. That's an effect that it's quite realistic, and it's. I think our brain processes that and makes us think that's quite realistic, and that's something that I use. And then velocity map pass, where you. It's again a smearing thing, so things move and smear as they have acquired some a relative velocity to other things in the scene. So something that would run here would smear its pixels across, while the things in the background wouldn't. And other post-processing things like passes like the depth of field, where you get the depth map, the Z buffer, and then you blur based on this information. And I also have a pass for fine-tuning, again, just a little bit, the saturation and contrast of all colors. So as you can see, there are quite a few passes. But the good thing about this is that once you do this, once you have this pipeline there, done, you don't have to worry about that anymore. You know the problems associated with the pipelines, what it can do, and from then on, you can work your imagination. So that's, unfortunately, it's not a very good one, because I on this laptop couldn't get a better screenshot, but this is a screenshot from our demo for tomorrow. And as you can see, there are a lot of details that without these passes wouldn't look actually any good at all. So you see all this darkening at the creases and how the light interact. Unfortunately, you have to see it in action. So yeah, wait until tomorrow, I suppose. Now, yeah, while you would do that, I think that you can, if you use one shader to do all of your tricks, you can copy paste it all the time and assign a new shader each time to a new object. So you don't have to load anything like 3D Studio to make a new material, just alter the shader. In other words, have all your materials, all your interactions of your object, the appearance of the object, as part of the shader. And it's so much easier then to emulate things like things that even have animation, like ice breaking, and to have much more control. And you can do that while the demo is running. So effectively, going back to the first question that I asked myself, why would you use a scripting tool and not a C program? Isn't it the same? Effectively, my scripting tool is the shader language. The shader language is a meta language. It's taken, an interpreter makes it into another form, GLSL or CG, and then it's sent to the graphics card. So if I can change that text document, basically, and update it in real time, then my faces will change. So it's more or less the same thing as having, okay, I don't have the lines and all the fancy graphics, but if you've reached this level, you must understand time in terms of numbers rather than lines, and that could be good enough. Going into colors, I try to use a maximum of 3 different color gradients in the scene, and usually I don't use, but you can. There are these color sim designers that you can find online, where you get a principal color, let's say red, and it will give you other 2 colors that actually look quite good, and you can use the gradients in between them and black or white, and that looks quite good. I have a shader on top, which is dead easy to do, where it would analyze the color from RGB into hue saturation value, and then play around with these hue saturation value in real time per scene. You can have some functions associated, and then the shader would revert back to RGB. So you can change how the demo, you can change the whole feeling of the demo, how the demo looks like, just by changing a number. I say sometimes less is more, and these days it's quite in fashion to keep saturation quite low, so keep it grayscale. And sometimes I say, design-wise, these scenes can have more impact than colorful. I use this simple function that's given with OpenGL to look at, so we have 3 vectors: position of camera, direction of camera, and up vector. I haven't been using Splines. You may think, well, if you look at the demo, it has quite a lot of complicated camera scenes, and it's all a combination of sine and lines. Basically, think of it as this. We talked before about scenes, 1, 2, 3, 4, 5, 12 different scenes. Each scene, with regards to the camera, is a situation where you go from traveling in a line, so you have things happening, and your camera is traveling in a line, or being static, then things happening and the camera rotates around. Usually it's one movement like that, next movement like that, next movement like that, and so on. So the intermissions, what happens in between, you could say that are the opportunities you have to move from one mode of movement into another. If you think of it like that, then I think you can generate a lot more in between your scenes. Usually I see demos where they have, for example, an object in the middle, camera rotating, then something else completely different, laid down, and then camera moving like that, and then nothing happens in between. If you were to use this movement where line, circle, then I think you could get a lot more content in your demos. Another problem we have, I didn't say that much about music, but I think I should now, because it's a hell of a problem if you have an 8-minute demo. Yeah, how do you fuse music and visual? Which comes first and which comes second? Usually people have the music first. We finish almost all of the visuals first, and then we write the music. And that's very, very hard. And it is hard. There is no magic way around it. And now I'll tell you how I do it. Let's say I agree with the musicians that we're going to have one scene that lasts, let's say, 30 seconds, or within, as I say, within that number, more or less, let's say, give or take a few seconds. Then another scene that's 30 seconds, 40 seconds, and so on. So they agree on that. Of course, with their music, the beats per minute is a fixed number. Then, of course, they are off sync when I get the music, because the visuals don't actually fit, and the music, they don't fit together. So what I do instead, I just stretch the demo a little bit. If you take this is basically, sorry, I should have made it more simple, but this is, if you think of it as a function that goes 0, 1, 1, and then goes down a bit, and then continues to be 1. So it begins as 1, it ends as 1, and then there is a little blip there where it goes under 1, maybe 2.9 a minimum. Now the time is the integral of this, so the time has slowed down for this section. Now if I do the same and I have a plus here, in the next scene, then time goes up. The integrals of these two things are going to be 0. They will cancel each other. So my demo is going to have exactly the same duration as before, only that the end of the first scene is going to happen slightly earlier than the beginning, than what it used to be. And that's a clever way of doing it. Of course, that assumes certain things. It's not 100% correct. It assumes that the frame rate is correct and the integrals are such as calculated to perfection. But I'm sure you can work out a better way of calculating integrals. Yeah, it really is not a problem. Speaking about design, typical demo, you would have an introduction, like a composition you would do at school, have scenes, then you can apply some typography in between, then another scene typography. Typography is a very nice way, if you have a writer's block, to add something into your demo and just keep going. And there's quite a lot of things that you can say, within typography. Yeah, you have credits, you have title, you have the name of the group, name of the event, and sometimes you might have text. I have used typography on all sorts of different situations. I've used typography as objects that look something that, and they transform into that object. Typography is actually extremely important. You should always remember that it might sound like a last resort solution, but it is there, and you should use it to that extent. Some trends that have been going, you know about all of these things. I suppose I mentioned typography. These are the kind of things that we use in demos. We're using. Ideally, you want to see something different, but for beginners, that's how you would start making your demos. And then you get to transitions. We talked briefly a little bit about transitions, moving with the camera and so on. As you might have guessed, I believe that if it's obvious, if people think, oh, there is a transition now, then it's not successful. You have failed. Transition must be so good that people shouldn't be able to tell where one thing starts and where one thing ends. And you should do that while keeping the frame rate constant. And I think that can lift a demo from just being average to really, really good. There are different ways that you can use transitions. I said I try to reduce the number of transitions for this reason. Fade-ins and outs actually aren't that bad if you don't use them every 10 seconds. I suppose maybe every 40, 50 seconds, it's fine. There are some others which have been used in lots of other demos, like something goes in front, then something happens behind it, and then that thing that was in front goes away, or you have flashes and things change, or you have some clever effects like the render to texture, and the next scene is part, let's say it's a painting. So you had a scene before, it's rendered into texture, the camera pans out, and then that scene is part of a texture that's inside a picture, let's say, and that picture is in a house or something. And these are all okay, but as I said, try to not use so much of that, because it looks like you've run out of idea, run out of ways to progress into the next scene. I think it's not a technical issue. There are lots of ways, as I said, to do good transition, but think of the story. Think of the story. How do you move from one scene into the other? Maybe you can spot something that's in common between the scene that you're working on and the scene that is coming. This common thing would be shape, could be color, it could be something else that is meaningful. And it comes through observation of what things have in common in life. Maybe chairs, record players, streets, maybe they have something in common, maybe they don't. If they don't, maybe you can use something else and move from one to the from one domain into another, and that would make an interesting transition. Talking about content and what to put in our in the demos. Yeah, talking about, I'm not quite sure about this, because I'm going to talk to you about content, how we generate that in ASD, but you probably might have different or better ideas how to do things. Now these days I'm quite into surrealism, so I understand that sometimes realism can be a bit blunt, because computer games do realism, okay, and they will always do. A lot of them will do realism, and they will always do it better than us because they have more resources. Because we make the demo where 5 people, 1 people doing the code, and we work for a few months, and they have 30-odd people working on a game, and they've done it many times before, and they are professionals. But they have to obey, and that's where we have the relative advantage. They have to obey the rules of realism because that's what the gamers want to do. They want to drive cars. They don't want to drive fishes. So now you come and you say, I can connect different worlds that don't adhere to any rules. It's your own universe, and you don't have to drive cars. You can drive whatever you like, and that's what will make relatively more interesting, what will make your demo more interesting than a video game. So in surrealism, basically, we would merge two different distant realities that may have something or may not have something in common. But there is always a symbolism. And you can force this by changing scale, distorting things, distorting scale, distorting colors, distorting situations. I was talking about fishes, driving fishes. Fishes wouldn't be out of the sea. Then something else that doesn't go into the water could be in there. These would all be part of the same surreal world, and that's what would make your demo very interesting. How all these things that completely out of proportion and out of their own natural place are linked together, and that I think is a sign that you've put the extra thought into your demo. As some last advices from me, I say demos are all about cheating. Cheating, I don't mean to take somebody else's music or graphics without quoting and so on. I think it's about cheating your audience, the people who are going to watch it, to make them think that you are making something that is big and more clever than they thought it was going to be. Remember that we have very limited resources, while other groups, the games companies, for example, they have a lot more resources and they can do so much more. So use whatever little you have to create something that people will remember. It is your world, your cameras, and use every last second of it to inspire people. Let's say you finished your demo after all this. I say always give it a good name. Think of a good name that you would unite all of this together. And if you have the luxury of time, try to forget all about your demo and watch it after a couple of months, so you can see all the different errors that you've made, so that your brain will forget and then fine-tune. I guess at the end, you will eventually, with experience, you will know how much to put in and how much to take away. Always ask the same question to yourself: what will impress my audience? And with that, I finish my presentation, and I would like some questions from you on anything you would like to hear me talking about.
Hello.
Hello.
What do you think about completely abstract demos without any like?
I really like them, and I've made some myself. But this would have to be covered by a different presentation, because as you understand, what I've talked about are, at least the non-technical things, are completely irrelevant in this situation. And I understand that there are lots of different ways to make demo and lots of different schools of thought, and that's fine by me. But I talk to you more about the classical demo. Yeah, but I really admire them, and I have my, let's say, personal heroes in the scene that do demos, and I know that what looks like being very much easier to make than traditional demos, sometimes it's a lot harder when abstract, yeah.
Thank you.
So yeah, if you don't have anything else to say, to ask me about, my last words would be: if you've never made the demo, then I think you should. It's a really good experience, and it's much easier to do so than you think. And we are actually all a bunch of old farts now. We're getting very old, and we need some new blood. So we're doing the best we can to just get some of our experience and knowledge through to to you, lots of other people that I've talked to before. Yeah, just OpenGL or DirectX and C++ is good enough, and you can have a demo within 2 days. And who knows, maybe next year you'll be here and competing on the big screen, and you'll be, when that moment comes, you'll be very, very pleased that you tried to do so. So yeah, don't forget to come tomorrow to watch the demos, and I hope you enjoy all the show.